All right, this is first maybe two, maybe three videos on motor calculations. It'll depend on how long it goes out as far as time for each video. Try and keep them around 10 to 15 minutes. All right, so on the left side of the screen, you'll see a flow chart and some spelled out listings of articles and code sections for motors, which is 430, Article 430. When you get into motors, we'll start with conductors, since that's what we're going to start with first. You got to ask yourself, am I dealing with feeder conductors or am I dealing with the branch conductors? Okay, no, they're both in the same, under the same part, but you want to make sure you read that. Okay. Now, when we're talking about the overcurrent protected device, you want to ask yourself again, am I dealing with my branch overcurrent protected device or a feeder overcurrent protected device? Notice the feeders are in part 5, the branch is in part 4, so be careful there. Okay? And then let's talk about the overloads. The overloads for a motor, you only have one branch motor overloads, okay? But we have motor overloads there, and then we have thermal overloads, but they're both in part 3. Okay, notice they're in two different locations of this flow chart because these are in your starter, and this could possibly be in the motor. Okay, so be careful there. All right. Oh, I'm sorry. I was thinking that was electronic. Those thermal those thermal overloads are in the motor, so be careful there. So let's come on up here. First place you want to go is 430.6. This tells us about table values and nameplate values and when to use which. Okay, table values. More times than not, these are the tables here. Right, it's at the back of the 430. If we're looking for ampacity of the conductors, current rating of a switch, or the overcurrent protected device, we're going to use the table values, but that's not always the case. I'll get to that here in a minute. Now, this is not your current overcurrent protected device. This is kind of like a disconnect switch, a 60 amp switch, but you have 50 amp overcurrent protected device in it. Okay, so that's how what they're getting at. Excuse me. Now, the nameplate value, right here. Oh, yeah, right here. Your motor overloads, your separate motor overloads, that would be here. Okay, you're using the nameplate value. Okay. Now look at this: ampacity of conductors, current rating switch, and overcurrent protected device. If you have any of these motors, you're using the nameplate, not the table value. So if they give you any extra information whatsoever, there's a reason why. Pause and think about what you're doing on here, okay? Now, we're going to go cover single motors. Single motors are simply 125%. And we'll cover this more in class, but you'll find that most of your motor calculations will use 125% for conductors. Okay. Now we need this is nameplate values. Both of these are nameplate values. Nameplate. Okay. Both of these are. Okay. So that means we can't, when we're going to calculate conductors, we can't use this value or this value. Okay. So we have a 230 volt motor, 3-phase, so that's going to be table 250, and it's a 3 horse. So if you look up 3 horse, go over to 230 volt, that's 9.6 amps. It's not the nameplate value, is it? And now we're going to multiply by 125%. So 1.25 equals, and that would give us 12 amps. And then we simply go to our chart, our 310/16, and pick our conductor. Okay, Now, there is this little stipulation. You got to think about your breaker size. So it's not just going to 3, 10, 16. You got to look at your breaker size. If they don't tell you what your rating of your motor is, you can presume that it's 75 degrees. The termination points are 75 degrees. You can presume that. Okay. Now let's do this 460 volt motor. Okay. It's 460 volt. Nameplate is 4.3 amps, so we can't use that, but we got a 3 horse. So 3 horse, 460 volt is 4.8 amps. So we made in our calculation so far, it's not going to make a difference, but we do what we're told to do and we follow the code. Again, 1.25, and if you take 4.8 times 1.25, you get 6 amps. Okay, so 6 amps for those conductors. Right now, I think it's safe to say we can put both of those on 14 gauge wire. Okay, so now we'll keep on going. All right, here's our overcurrent protective device. Okay, excuse me. Okay, so it tells us to use this table right here. Okay, now this is branch circuit. I am not getting into the feeders in this video, just a branch circuit. So, and it depends on, am I doing a non-time delay, dual element, instantaneous trip, inverse time breaker? I'm just picking one and going with it. Okay, so I already know that this was 9.6 amps from previously, and this other one was, what was that other one? It's 4.8. 4.8 amps. So I can't use those, right? Okay, I got these from the tables, that table 250, right? So now, if I'm doing let's do a dual element. We'll do a dual element, okay? And it's an induction motor, okay? So we got to find it. DC constant voltage, wound rotor, synchronous, squirrel cage, no. AC polyphase motor, nope, it's an induction. So we go with the single phase motor. So if we're doing a dual element time delay, it's 175%. So 9.6 times 1.75, right? Because these are percentages. That's a percentage. So 9.6 times 1.75 is 16.8 amps. Whoops, I clicked my button. Dadgummit. All right, I'm back. So I believe we said this was 16.8 amps. 16.8 amps. So then we want to read through the notes. Okay. Read through the paragraph that occurs before this table, telling you about when you can go up to the next higher breaker and all that. So I think it's safe to say that we can use a 20 amp breaker in this, right? And without even looking, I bet 14s are still good because it's a 15 amp, right? When we do our derating, we can use the column that our insulation's in, right? So we won't get into that right now any further. Now, here we'll do this one. 4.8 times, well, this one will, I'll change my color here. Let's do inverse time for this one. Okay, so I'm going to forget about that. Oh, hey, that looks pretty nice. 4.8 times, again, we know we're using this one because my motor's not any of these others. So that's 250%, so 2.50 Okay, so 4.8 times 2.5 equals 12 amps. Okay, so 12 amps. And again, I bet we could put that on a 15 amp breaker, right? So 15 amp breaker. This was better select the right color. Come on. There we go. Breaker. Boom. Okay. And there's our breaker. And like I said, this one is 12. This one is 16. And we'd have to go to our tables, 310.16, and our 110.14 says 60 degree column. I believe, let me look that up real quick. Our 110.14C says 60 degree column since we're under a 100 amp breaker, and 14s are still good for 15 amps. Okay, and we'd have to go to a 12. So this one, let's pick it. So this one here, oops, this one here is the number 12 wire. Oh, I'm sorry, number 14 wire gauge. And this one has to be a number 12 gauge wire. Okay, that's going back using 110.14 C1. I believe that's the correct one there. Now, let's mosey on down here. 12. Okay, I think I can get this last part in and only make it one video. So, now, this is only for more than 1 horse. There's a B, that's for less, 1 horse and less. Okay, separate overloads. These are your overloads in the controller. Okay, we got thermal or electronically protected overloads. Okay, we got these. Okay, we won't get into details here, but these are the percentages that you want to use. Now C here is if these right here, I mentioned B was 1 horse and less. A1 is greater than 1 horse. That's these right here. Now, if your overloads aren't big enough to allow the motor to start, now you can use these percentages. So for right now, we're only going to deal with these, okay? Because we got a 3-phase motor right here. Boom. So I forgot to look what the service factor is and the temperature marking is on the motor, but we'll say it's at least 40 degrees or less than 40 degrees, and your service factor is at least 1.15. So we can use 125%. So we have to use the nameplate value now. So 8.6 times 1.25, and that gives us, let's see, 8.6 times 1.25 is 10.7. So we need an overload that can handle 10.75 amps. And then you go to the manufacturer's tables and select an overload that works for 10.75 amps. This one would be 4.3 times 1.25. So 4.3 times 1.25 is 5.375. 5.375 amps. And again, we go to the manufacturer's data tables and select the overload that will work for that amperage. All right, that is it. All right, made it all in one video.